Good morning, students. Pushti sir again today with a very conceptual topic for you, which is not explicitly discussed in the books, but this is extremely important, and I insist that all of you should understand in detail this concept and let the concept be get etched in your brain for making things easier for you in future. Okay, just see the topic name: work done by tension, normal reaction and friction forces. Okay, as usual my credentials, and this I'm going to use for constant equation. This I wrote here, important concepts. These are important concepts for constant equations. This is my lecture number 1. Lecture number 2 will follow as a sequence of this. Mark it and be careful, listen carefully and take it very seriously. First, let's discuss on the work done by a massless, massless, inextensible string and whose length cannot be increased. If an agent, for example, if any agent has to do any work, okay, again a grammatical error here, has to do, if any agent has to do any amount of work, then it has to spend energy of that much amount. It has to spend energy. It must have that much energy with itself to spend to do that amount of work. This is a common observation, law of nature. If the work done is positive, means it is doing, the agent is doing positive work, then energy of the agent has to decrease. He has to spend that much amount of energy. That's what I wrote here. The energy of the agent has to decrease by equal amount. And if the work done by agent is negative, some external agents are doing work on this agent, some external work is being done on the agent, then the energy of the agent has to increase by equal magnitude. He has to spend negative energy. That means his energy has to increase. Means the agent who has to do positive or negative work must have a storage of energy associated with it, so that it can either spend or it can increase. It implies that in order to do any work, the agent must be in a position to spend or increase its stored energy. Yes or no? Simple. Now let's come to the massless string, whose m is 0. Massless string, since m is 0, can it produce any kinetic energy? Half mv square, m is 0. No, it cannot. It cannot possess any, kinetic energy. Yes or no? Gravitational potential energy. If m is 0, what gravitational potential energy? Gravitational potential energy per unit mass is g only, gh only. So potential energy will be mgh. M is 0. So what gravitational potential does it possess? Nothing. 0. Because it cannot be extended, as it is inextensible, and it cannot withstand compression. You try to compress a string, become loose. It cannot withstand compression. Neither it can be extended, nor it can withstand compression. That means that it doesn't behave like a spring. So it cannot store elastic potential energy. Elastic potential energy depends upon the extension or compression. Neither is possible for a string. As its mass is 0, its capacity also 0. So it cannot store any thermal energy, It cannot store any elastic potential energy. It cannot store in kinetic energy. It cannot store in gravitational potential. It cannot store any energy. We conclude that a massless, inextensible string cannot store any mechanical or thermal energy. Full stop. Simple logic. If it cannot store any energy, then how can it spend or increase? It has no capacity of storage of energy, so neither it can increase any energy or it cannot spend any energy. Yes or no? So it cannot spend or increase its mechanical or thermal energy, as it is always zero. In all reference frames, this is true in all reference frames. So more accurately, if I say more accurately, its internal energy remains constant in all situations in every reference frame. खत्म, ठीक है? तो उसका एनर्जी कांस्टेंट है हमेशा, तो कांस्टेंट को जीरो भी मान सकते हो. So therefore the net work done per second, every second में work done, we sometimes we call this work done per second as power developed. So by a massless, net लिखा मैंने, by a massless inextensible string is always zero in all reference frames. मैं बहुत explicitly statement दिया, यूनिवर्सल ट्रू स्टेटमेंट, ठीक है. अभी हम आएंगे नॉर्मल रिएक्शन फोर्स के ऊपर. एक एग्जांपल दे रहा हूं, ये देखो, एक वेज है, रिजिड नॉन डिफॉर्मेबल, पॉइंट मास स्मॉल m है, वेज इज कैपिटल है. जस्ट नॉर्मल रिएक्शन फोर्स मैंने दिखाया, उसका कोई ग्रेविटी फोर्स, फ्रिक्शन फोर्स बिल्कुल कुछ नहीं दिखा. सो n कैसा, n1 किसके ऊपर एक्ट कर रहा है? ऑन द ब्लॉक, ऑफ कोर्स in this normal to the surface. n2 किसके ऊपर एक्ट कर रहा है? on the wedge, normal to the surface. ये मैं खड़ा हूं ग्राउंड पे, देख रहा हूं, उसका वेलोसिटी v2 है वेज का, लेफ्ट की तरफ मैंने लाइन लगाया. इसका वेलोसिटी ऑन द वेज के, वेज रेफरेंस फ्रेम तो अलोंग द इंक्लाइंड वो स्लाइड करेगा, लेकिन ग्राउंड रेफरेंस फ्रेम में ये जो v रिलेटिव है अलोंग द इंक्लाइंड प्लेन प्लस v2 मींस समवेयर लाइक दिस. आई डोंट नो एग्जैक्ट ओरिएंटेशन ऑफ v1, but some v1 will be like this. v1 is v of small m with g means with respect to ground, v2 is v of capital and h with respect to ground. ठीक है. अभी न्यूटन स्थान लॉ के हिसाब से n1 n2 दे आर एक्शन रिएक्शन पेयर है ना. तो क्या लिखेंगे न्यूटन स्थान लॉ के हिसाब से? n1 बार इज माइनस n2 बार एक्शन रिएक्शन पेयर. इक्वेशन ये हमारा ऑब्जर्वेशन. सो अभी वर्क डन बाय n1 एंड वर्क डन बाय n2 दोनों हम कैलकुलेट करेंगे. दिस इज डेफिनेशन ऑफ वर्क डन. n1 डॉट v1 दैट इज द वर्क डन बाय n1 force, work done by n per second, the dot v1. So work done per second by n2 force is n2 dot v2, because n2 is acting on the wedge and point of the wedge having a velocity v2 to the left. So work done by both action reaction pair of n1 and n2 is how much? n1 v1 plus n2 v2. दोनों ऐड कर दो, इक्वेशन 2 3. इक्वेशन 1 से हमको क्या मिला? n1 is equal to minus n2. सो n2 की जगह माइनस n1 लिख दूंगा और n1 को कॉमन ले लूंगा. क्या आएगा? v1 माइनस v2. बट यू नो v1 माइनस v2 इज v रिलेटिव v12. ठीक है ना. सो दिस वर्क डन बाय पर सेकेंड बाय एक्शन रिएक्शन पेयर ऑफ नॉर्मल रिएक्शन इज n1 डॉट v12. दिस कुड हैव बीन रिटन एज n2 डॉट v21 आल्सो. ठीक है ना, कोई दिक्कत नहीं है. n1 bar is a real force. As you know, real forces are same from all reference frames. v12 is relative velocity of m with respect to capital M. इधर थोड़ा सा केयरफुली देखो. is same from all translating reference frame. मैं ये translating reference frames बोल रहा हूँ, मतलब है कि कोई reference frame का कोई रोटेशन ना हो तो अच्छा है. रोटेशन होने से क्या होगा मैं बताऊंगा आपको, लेकिन फॉर ऑल ट्रांसलेटिंग रेफरेंस फ्रेम V12 इज सेम, है ना। V1 may be different, V2 may be different from with respect to translating reference frame, but V1 minus V2 will be same. For example, with respect to wedge reference frame, this will be V1 will be like this, V2 will be not, V2 will be not there with respect. If suppose somebody is standing on the wedge, he will not see V2, he will see V1 plus V2 in opposite minus V2. So some observation will make, and that will be along the inclined plane. Okay, and for every observer will see that the block will be sliding along the inclined plane. That's what I'm saying. V1 to be relative is same from all reference frames. Okay, that proof we can give in detailed manner, but I think you should have known by it now. This is for translating reference. Okay, रोटेटिंग रेफरेंस में क्या होगा मैं आपको ये रेड लेटर में लिखा है. So with respect to wedge reference frame, V12 is which wedge reference frame के हिसाब से, with respect to that V12 will be along the inclined plane only, and N1 will be perpendicular inclined plane. What is the angle between N1 and V12? 90 degree. Yes or no? So with respect to wedge reference frame, V12 is along the inclined plane. So therefore, with respect to ground reference frame also, the V12 is along the inclined plane, because V12 is same from all reference frames, and N1 is perpendicular to inclined plane as observed from all reference frames. So N1 dot V12 is 0 from all reference frames. Yes or no? So that is with respect to all reference frames. Okay, so we conclude that from equation 4 and 5 together, we conclude this equation, work done by action reaction pair of normal reaction, and N1 dot V12 is equal to 0. These two equations, from this, what we conclude, that work done per second by all reference frames, work done per second by action reaction pair of normal reaction forces is 0 from all translating reference frame. Okay, मैं रोटेटिंग रेफरेंस फ्रेम को हिसाब में अभी तक नहीं लिया. चलो नोट में क्या लिखा मैंने, वर्क डन पर सेकेंड N1 by N1 alone or N2 alone can be either positive, negative or 0. It is always possible. But what I just discussed, work done per second by N1 and N2 together, the action reaction pair of normal reaction together, is always 0 from all translating reference frames. है ना, from all translating reference frames. Second point, very carefully you see, if a rotating reference is considered, relative velocity of two particles can be different as observed from translating reference frames to rotating reference frames, because for rotating reference that one angular velocity will be there, so omega cross R1 and omega cross R2, two factors will be there. They will make the relative velocity with respect to rotating reference frame different from translating reference frame. But ये mark करिए statement. But if the coordinates of the two particles coincide, because omega cross R1 and omega cross R2, these two velocities, extra velocities we will see from the rotating reference frame, and their subtraction we have to do for the relative one. The subtraction need not be 0. So that omega R subtraction, if it is 0, then the relative velocity with respect to translating as well as rotating reference frame will be same. Okay, but if it is but if the coordinates of the two particles coincide, then the omega r1, omega r2, both r1, r2 same, so they will cancel out. So the relative velocity will be same with respect to rotating reference frame as well as translating reference frame. So the relative velocity of the two particles as observed from translating reference frame and rotating reference frame is same. Block letter I have written. If the coordinates of the two particles coincide, come to this. The coordinate of M and the touching point of the wedge, there is same, the touching point wedge is moving with V2 and point particle is moving with V1. They are having same coordinate point with respect to any reference frame, even with respect to rotating reference frame also the same coordinate point at that instant. Every instant the touching point, the particle and the touching point wedge will have same coordinate point. So what is the note 2 says? If the coordinate points of the two particles are same or the coordinates of the two particles coincide, the relative velocity of the two particles as observed from translating reference frame and rotating reference frame is same. Okay, since the block and wedge touch at a common point, so V12 is same from the rotating reference frame also. Therefore, we conclude that work done per second by a pair of action, reaction, normal reaction force is 0 from all reference frames. मैं all को underline कर दूं, आपका परमिशन के साथ मैं इसको अंडरलाइन कर देता हूं. ठीक है, ये समझ में आ गई. बार बार पढ़ना. इसका भी डेफिनेशन डेरिवेशन हम डिटेल कर सकते हैं, बट अभी फिलहाल उसको छोड़ते हैं, तो कोई बड़ा डेरिवेशन भी नहीं है. देन पॉइंट नंबर 3 में आएंगे. क्या है वो? वर्क डन बाय फ्रिक्शनल फोर्सेस. ये पॉइंट नंबर 2 का क्या था? वर्क डन बाय नॉर्मल रिएक्शन फोर्स. ये पॉइंट नंबर 3 में क्या लिखेंगे? वर्क डन बाय फ्रिक्शनल फोर्स. अंडरलाइन कर देता हूं तो आप भी खुश हो जाएंगे. चलो ठीक, अभी सेम डायग्राम में आ जाते हैं. बस अभी इधर खाली में फ्रिक्शनल फोर्स दिखाया, N1 N2 नहीं दिखा रहा. ये देखो, ये पॉइंट मास स्मॉल n, उसके ऊपर फ्रिक्शन फोर्स सपोज इज स्लाइडिंग डाउन, so friction force F1 will be of the incline and उसका reaction friction force है और the wedge के ऊपर at that same point of contact will be F2 down the incline. ये दोनों अलग से भी दिखाई इधर. ये V1 है, ये V2 है, कोई वो नहीं है. ये फ्रिक्शन फोर्स है F2, ये F1. क्या करूं, उसके ऊपर मैं थोड़ा ये कर देता हूं, वेक्टर सिंबल दिखा देता हूं, तो आप नहीं तो चूचू करेंगे भाई वेक्टर किधर गए. ठीक है. So F1 is frictional force on small m and F2 is frictional force on capital M. They are opposite to each other as you can see because they are action reaction pair. F1 bar is equal to minus F2 bar because जब न्यूटन था लो, ये मैं ग्राउंड में खड़े होके देख रहा हूं. So work done by F1 कितना होगा? F1 dot V1 as usual, that was N1 dot V1, I'll say F1 dot V1. चलो, similarly work done by F2 will be F2 dot V2. By work done per second by F1 and F2 together, how much? F1 dot V1 plus F2 dot V2. ठीक है ना? बट F2 क्या है? माइनस F1. ये इक्वेशन 6 से लगा दिया मैंने, तो F1 को कॉमन ले लिया, तो V1 इसमें लिख देता हूं. ये डॉट को थोड़ा सा कभी कभी नजर नहीं आ रहा. डॉट V1 माइनस V2, दैट इज V12. सो F1 डॉट V12 इज द वर्क डन बाय एक्शन रिएक्शन पेयर ऑफ फ्रिक्शन फोर्सेस. समझ में आ रही है? तो आज डिस्कस इन पॉइंट नंबर 2. ये जो पॉइंट नंबर 2 मैंने किया, इसमें ये पॉइंट नंबर 2 मतलब ये जो है मेरा जो नॉर्मल रिएक्शन में जो पॉइंट नंबर 2 है उसमें क्या लिखा, N1 N2 they are real forces, obviously same from all reference frames. Similarly, F1 F2 में लिखा इधर N1 being real force is same from all reference frames, so as N2 also. ठीक है, so F के लिए सेम करेंगे, F1 is same from all reference frames because just like N1 is same from all reference because a real force, F1 also same from all reference frame, in all reference frame being a real force. V1 is also same as observed from all reference frames including rotating reference frame. ये हमने बहुत एक्सप्लिसिट डिस्क्राइब किया आपको नोट में, नोट का पॉइंट 2 में इसे मैं लिख दिया, रेफर टू नोट पॉइंट 2 above. So also you know F1 and V12 must be opposite to each other, as you know from the property of friction force. Friction force will always be opposite to relative velocity. So F1 dot V12 will be -1 because they are 180 degree opposite to each other. Magnitude of F1 bar magnitude of V12. So this is work done per second by action reaction pair of friction forces as we see from equation 8. So ये हो गया आपका work done by action reaction pair of friction forces, the work done per second. नोट में क्या लिखा, work done by F1 और F2 alone, F1 alone or F2 alone can be positive, negative or zero. But the work done per second by F1 and F2 together is always either negative or zero. It can never be positive because this is a magnitude, and -1 multiplication makes it whole thing either negative or zero. Zero means when either of any one of these two is zero. Okay. So when it will be negative zero, when F1 or F2, ये और की जगह मैं ठीक से नहीं लिखा, इसको मैं when F1 is equal to 0. Obviously F2 will be a reaction of that will be 0. So that is the same thing. Automatically F2. ठीक, और ये दोनों नॉन जीरो हो भी सकते हैं, और V12 is 0. V12 means the relative velocity between the small m and the touching point of small m and wedge. Okay, so V12 the relative velocity is 0. तो कब होगा relative velocity 0? जब वो स्लाइड करेगा ही नहीं तो relative velocity 0 है. F1 F2 may not be 0, but relative velocity 0 when there is no sliding. ये भी मैं एक लिख देता हूं, either static, mass और रोलिंग विदाउट स्लिपिंग. ये दोनों केस में V12 0. टचिंग रोलिंग में स्लिपिंग क्या होता, द टचिंग पॉइंट has zero relative velocity, है ना, the contact surface point have zero relative velocity. That is the rolling without slipping case. But whenever there is slipping, V12 is non-zero and friction force is not 0, then the work done per second by action reaction pair will always be negative. If slipping velocity is non-zero and friction force is non-zero, the sliding velocity non-zero, friction force non-zero, then obviously the work done must be negative. If any one of them, either friction force 0 or the sliding velocity 0, in two cases sliding velocity when static mass, static block, or the rolling without slipping, like a cylinder rolling down the inclined wedge, or a sphere rolling down the wedge, the relative velocity at the touching point is 0. That is known as the relative velocity at the touching point is defined as sliding. So that when sliding is 0, that is V12 is known as sliding velocity. V12 0 means sliding velocity 0. So then also friction force, action reaction pair of friction force will do 0 network per second. So work done per second by action reaction pair of friction force I can write as -1 into magnitude of friction force into relative speed at the point of contact. ठीक है, तो किस केस में 0 होगा मैंने लिखा आपको इधर. और and also I have seen the individual friction force. Remember, individual F1 or individual F2, they can do all three types of work: negative, positive, or 0. But together they can do only 0 or negative work. Positive work बिल्कुल नहीं कर सकते. And together an action reaction pair of normal reaction forces will do 0 work always. And in this valid in all reference frames, including the rotating frames also, as I have explained in the note point 2 after the normal reaction work done section here. Okay, because the point of contact between the small m and the capital M, the point of contact has a common coordinate at every instant. That's why with respect to rotating reference frame also, all the statements are valid. B12 is same from all the translating reference frames as well as rotating reference frames also. Okay. Any difficulty? If you have got any difficulty, please come forward and ask me. I'll very soon go to the next lecture where I'll be using certain points here in deriving the constraint equation, the string constraint as well as wedge constraint, so that you will have the whole thing will become so easy for you. Okay. So, all the best for your upcoming examinations. Have a good day. Thank you all.